Chapter 10 introduces short-run economic fluctuations, the importance of sticky prices, and aggregate demand, aggregate supply model. And the classical model developed in earlier chapters explains the behavior of key macroeconomic variables in the long run. But the task of macroeconomics may go beyond this, and macroeconomists and policymakers are also concerned with the year-to-year and quarter-to-quarter fluctuations of the economy, and the irregular fluctuations in GDP and corresponding fluctuations in other macroeconomic variables are known as the business cycle. So in this chapter, you will learn facts about the business cycle, how the short run differs from the long run, and then an introduction to aggregate demand, an introduction to aggregate supply in the short run and long run, and finally how the model of aggregate demand and aggregate supply can be used to analyze the short run and long run effects of shocks. Here are some of the facts about the business cycle. 1. GDP growth averages 3 to 3.5% per year over the long run, with large fluctuations in the short run. And 2. Consumption and investment fluctuate with GDP, but consumption tends to be less volatile and investment more volatile than GDP. 3. Unemployment rises during recessions and falls during expansions. And finally, 4. Econ's law. That is, there's a negative relationship between GDP and unemployment. So next 4 slides we'll see that follow this provides data on each of these points. Here, the shaded vertical bars denote recessions. And in the United States, the NBER is the official arbiter of when recession begin and end. And as you see in this graph, over the long run, real GDP grows about 3% per year. And over the short run, though, there are substantial fluctuations in GDP. And the graph also shows consumption. That's in orange, which seems to be less volatile than income, which is in blue. And consumers prefer smooth consumption, so they use saving as a buffer against income shocks. This graph shows consumption growth and GDP growth, but now the vertical axis has a much bigger scale to accommodate the addition of investment growth, which is in green. And as you can see here, investment is far more volatile than GDP or consumption. And investment here includes business equipment, structures, new housing, and inventories, and they tend to fluctuate or change in a rather larger proportions than household consumption. This graph shows the US unemployment rate, and the unemployment rate rises during recessions and falls during expansions. As you see, since 1991, during that recession and on, the unemployment rate lags GDP growth, particularly in recoveries. In each of the 3 recessions since 1990, the unemployment rate continues rising for a few months after recession ends before it begins to fall. The economist Arthur Econ suggested a rule of thumb, which has become known as Econ's law. And this is the plot of Econ's law. That is, vertical axis you have percent change in real GDP, and horizontal axis change in unemployment rate from the previous year. And each dot represents each year. And if you look at the trend line of the dots, then you see that there's a definite negative trend. And if you use statistical techniques, you can estimate the Econ's law equation on page 285 for this particular case. So the estimation is this: percent change in real GDP equals to 3% minus 2 times change in unemployment rate. So this relationship states that if the unemployment rate is unchanged, then the real GDP will grow at its potential rate of about 3%. Also, if unemployment rate were to increase by 1 percentage point, then GDP growth will fall by about 2 percentage points. And if unemployment rate, let's say, rises from 3% to 5%, that means percent change in real GDP should be equal to 3% minus 2 times 2%, which equals to 3% minus 4%, and at the end it equals to negative 1%, which implies a recession. Economists often need to develop forecasts of where the economy is heading in the future. One approach is to consider so-called leading indicators. That is, the economic variables that typically fluctuate in advance of overall economic activity. And the index of leading indicators in the US is published monthly by Conference Board. And this aims to forecast changes in economic activity 6 to 9 months into the future. And this is used in planning by businesses and government despite not being a perfect predictor. These are the components of the leading economic indicator index. You can see page 287 to 289 for detail. And this is the plot of index of leading economic indicators from 1970 to 2012. And the index turns downward a few months to a year before almost every recession, as you see, and upward just prior to the end of almost every recession. Even though the index is a very imprecise forecasting tool, but it is used as an input into decisions by businesses and government policymakers. Now we finished looking at a few facts about the business cycle. Let's discuss about the time horizons in macroeconomics. In the long run, prices are flexible and respond to changes in supply or demand. On the other hand, in the short run, many prices are sticky at a predetermined level, and the economy behaves much differently when prices are sticky. Let's now recap what we learned in chapters 3 to 9, the classical macroeconomic theory. We learned that in classical macroeconomic theory, output is determined by the supply side, that is, supplies of capital and labor, and level of technology. And changes in demand for goods and services only affect prices, not quantities. And classical macroeconomic theory assumes complete price flexibility. And finally, it applies in the long run. On the other hand, when prices are sticky, that is, in the short run, output and employment also depend on demand, which is affected by 1. Fiscal policy, that is, government spending and tax, and 2. Monetary policy, that is, money supply changes, and 3. Other factors like exogenous changes in consumption or investment. And the basis of our short-term model of the economy is price stickiness, and the implications of sticky prices are far-reaching. 1. When prices are sticky, GDP need not always be at its natural rate. And 2. Further, monetary and fiscal policies can affect the level of output in the short run. These ideas are set out in the model of aggregate demand and supply, which is the paradigm most mainstream economists and policymakers use to think about economic fluctuations and policies to stabilize the economy. And this model shows how the price level and aggregate output are determined and shows how the economy's behavior is different in the short run and long run. Now let's start the topic with aggregate demand. The aggregate demand curves show the relationship between price level and the quantity of output demanded. And for this chapter's introduction to the aggregate demand, aggregate supply model, we use a simple theory of aggregate demand based on the quantity theory of money. And then in chapters 11 and 12 that follows, we'll develop the theory of aggregate demand in more detail. Recall that from chapter 5, the quantity equation says MV equals PY. Then for given values of M and V, this equation implies an inverse relationship between P and Y. That is, when price level goes up, then real money balances goes down, and Y, the real GDP or income, should go down. On the other hand, a lower price level P going down increases the real supply of money and therefore implies a greater volume of transactions assuming fixed velocity and increased Y. So increase in price level causes a fall in real money balances, therefore cause a decrease in the demand for goods and services. So Y falls because velocity is constant. And then you can draw a downward sloping AD curve that shows the negative relation between price level and Y, the aggregate demand. And since the AD curve is drawn on a diagram with P and Y on the axes, you will shift if either M or V changes. That is, if the money supply M is reduced holding V fixed, that means reduction in M will lead to reduction in real money balances. Therefore, will reduce Y and AD curve shifts in. On the other hand, the opposite is true if money supply increases, because an increase in the money supply shifts the AD curve to the right, because as money supply increase, real money balance is increased, therefore increase aggregate demand, or Y. In other words, for a given value of P, an increase in M would increase real money balances, and the output must rise at each P in order for the real money demand to rise to the higher supply of real money balances. Therefore, Y increases for given P, thus AD shifts to the right. You can also view increase in aggregate demand as increase in price level for given Y as well. If you view it either way, you will see a shifting out of the AD curve to the right. Now let's discuss about the aggregate supply. Aggregate supply gives a relationship between the general price level, P, and the quantity of goods supplied. And we need to consider two cases. One, the long run, when all prices are flexible. And two, the short run, when some prices are sticky. And let's first discuss aggregate supply in the long run. Now recall from chapter 3, in the long run, output is determined by factor supplies and technology. And the white bar is the full employment or natural level of output, also called potential GDP, at which the economy's resources are fully employed. Here, full employment means that unemployment equals its natural rate, not necessarily zero. We also know that the long run analysis is conducted entirely in real terms. In other words, the supply of goods and services in the long run does not depend on the price level in the economy. This means Y bar does not depend on P, so long run aggregate supply curve is vertical. Now note that one useful way to think about this model is in terms of equilibrium in different markets. That is, the long run aggregate supply curve summarizes a situation where the factor markets in the economy are in equilibrium, and given that these markets are in equilibrium, we know that the supply of goods and services must equal Y. So the AD curve summarizes a situation where the money market is in equilibrium. Now, with this in mind, let's look at the long-run effects of an increase in money supply, M. So when M increases, M over P increases, therefore aggregate demand increases. That is, for a given Y bar, it increases price level. So an increase in M shifts the AD curve to the right. And the equilibrium for the economy moves from point A to point B. And the shift in AD affects only prices. That is, because the AS curve is vertical, in the long run this raises the price level, but leaves output the same. Note that the results in this graph are exactly as we learned in chapter 5. That is, a change in money supply affects the price level but not the quantity of output. Now let's discuss aggregate supply in the short run. In the short run, many prices are sticky. For now and through chapter 12, we assume all prices are stuck at a predetermined level in the short run. And firms are willing to sell as much at that price level as their customers are willing to buy. Therefore, the short run aggregate supply curve is horizontal, as seen in next slide. And as we assume, then prices are stuck in the short run, the short run aggregate supply curve is horizontal. That is, the price level is fixed at a predetermined level. and firms sell as much as buyers demand. Now let's see the short-run effects of an increase in money supply M. So in the short run, when the prices are sticky, that is fixed at P bar, implying horizontal aggregate supply curve, an increase in M will lead to an increase in aggregate demand, and this causes output to rise from Y1 to Y2 as AD shifts from AD1 to AD2 to the right, and price level stays the same in the short run by assumption. Now your question is, what about unemployment rate? Well, we learned that earlier, Econ's law, which state that unemployment and output are negatively related. And in this graph, in order for firms to increase output, they require more workers, therefore employment should rise, and unemployment rate should fall. So in the short run, the price is stuck. However, over time, prices gradually become unstuck, and when they do, would they rise or fall? And you can construct a table to show 3 different case scenarios. The first is, in the short run equilibrium, if y is greater than y bar, then over time P will rise. That is, if AD is higher than the full employment level of output y bar, there's upward pressure on prices because the firms must pay higher costs of labor over time, and also higher cost of maintenance over time and repairing over time, and also increased depreciation of capital that will lead to increase in price level. And the adjustment of price is what moves the economy to its long-run equilibrium. And the opposite will hold true when y is less than y bar. That is, over time, price will fall. And third case, when y is equal to y bar, then nothing changes. So the adjustment of prices is what moves the economy to its long-run equilibrium. So here, the economy starts at point A. Output and unemployment are at their natural rates, and price level is P bar. Then the Fed increased money supply, and that's going to increase aggregate demand. It's going to shift the AD curve from AD1 to AD2. So in the short run, prices are sticky, so output rises from Y bar to Y2, from A to B. In order for firms to increase output, they hire more workers, so unemployment falls below the natural rate of unemployment, putting upward pressure on wages now. And the high level of demand for goods and services at point B puts upward pressure on prices. So over time, as prices become unstuck, they begin to rise in response to this pressure, and as price increases from P bar to P2, moving along the new AD curve from B to C, output Y start falling and falls from Y2 to Y bar, eventually moving along the AD2 curve. So at the end, you reach point C, the long-run equilibrium, where at the end, you go back to Y bar, the natural level of output. Correspondingly, you're going to go back to natural level of employment. So at the end, in the long run, compared to short run, price level rises from P bar to P2, and output stays equal to point A, initial level. And natural level of unemployment stay the same in the long run as in the beginning. So using this diagram, you could see both short run and long run effects. And this is a good model to learn in helping you to analyze the effect of money supply on output and prices in the both short run and long run. Now let's analyze the shocks, the short run and long run effects. And shocks are exogenous changes in aggregate supply or demand. And the shocks temporarily push the economy away from full employment. Now let's first look at a demand shock. For example, exogenous decrease in velocity. And if the money supply is held constant, a decrease in V means people will be using their money in fewer transactions, causing a decrease in demand for goods and services. So using quantity theory of money, we could see that when velocity V falls for given Y, this will lead to, for given M, increase in real money balances, therefore decrease in price level for each Y. And this will have same effect of decrease in AD, aggregate demand shifts left. depressing output and employment in the short run from A to B. So output falls from Y bar to Y2, and unemployment rate rises by Okun's law higher than natural level of employment. Then over time, prices fall, and the economy moves down its demand curve toward full employment from B to C. So note the economy self-correction mechanism. When in a recession, the economy, left to its own devices, fixes itself. That is, the gradual adjustment of prices helps the economy recover from the shock and return to full employment. That is, Y2 to Y bar again. But the price level fell from P bar to P2 eventually. Of course, in the short run, before the economy has finished self-correcting, a period of low output and high unemployment is endured. Next, let's analyze supply shocks. A supply shock alters production costs, affects the prices that firms charge. And this is also called price shocks. And examples of adverse supply shocks, which is related to increasing costs, therefore increasing prices, are 1. Bad weather that reduces crop yields, pushing up food prices, and 2. Workers unionize, which would negotiate wage increases, and 3. New environmental regulations that require firms to reduce emissions, therefore firms charge higher prices to help cover the costs of compliance. These are examples of adverse shocks. On the other hand, favorable supply shocks actually lower costs and prices, and has the opposite effect of adverse supply shocks I just listed. Now let's look at a couple of examples of supply shocks. First case study we want to look at is the 1970s oil shocks. So early 1970s, OPEC coordinates a reduction in the supply of oil. And oil prices rose 11% in 1973, 68% in 1974, and 16% in 1975. And sharp oil price increases are supply shocks because they significantly impact production costs and prices by increasing costs and prices significantly. So the oil price shock shifts the short-run aggregate supply up, causing output and employment to fall. And by Okun's law, as output falls from Y bar to Y2, we would expect to see unemployment increases above the natural rate of unemployment. So from A to B, price level goes up, that's the shock, and it's going to decrease output from Y bar to Y2 and increase unemployment, where new unemployment rate is higher than natural rate of unemployment. And in the absence of further price shocks, what is going to happen is prices will fall over time eventually. So moving back along the AD curve, as prices fall, the economy moves back toward full employment, going back to point A, returning to Y bar, returning to natural level of employment, and returning to the initial price level P1 bar. And this plot summarizes the model's predictions and supported. That is, as you see in this plot, as price level rises, inflation rate rises, output falls, and unemployment rate increases. And then you see that the opposite holds true, as when oil price falls, CPI inflation rate falls, and following with a lag, unemployment rate falls. So this plot supports the predictions of the model. And the second oil shock happened in late 1970. From 1979 to 81, the second oil shock occurred due to revolution in Iran. That is the demise of the Shah of Iran, and Ayatollah Khomeini, Iran's new leader, was much less friendly toward the West. So in late 1970s, as the economy was recovering, oil prices shot up again, causing another huge supply shock. And as you see in this graph, this leads to increase in price level with the oil price increases, and what followed is the increase in unemployment rate. And then eventually, oil prices falling, following inflation rate. On the other hand, in 1980s, there was favorable supply shock. That is, a significant fall in oil prices occurred. And as the model predicts, inflation and unemployment fell. that is in the short run. As you see in this graph, with oil price falling, as output increases, unemployment rate falls. So oil price fell 8.7% in 1982 and continued to fall until 1986, when it fell the most, that is 44.5%, and following the unemployment rate that was falling. Now let's briefly discuss about the stabilization policy. So stabilization policy is the policy actions aimed at reducing the severity of the short-run economic fluctuations. For example, using monetary policy to combat the effects of adverse supply shocks. So as you see here, the adverse supply shock moves the economy to point B. And here what the Fed can do is this. If the Fed correctly anticipates the sign and magnitude of the shock, then the Fed can accommodate the shock by raising aggregate demand, by increasing money supply, as you learned before. And the result would be at point C at the end. That is, price level permanently becomes higher at T bar 2, but Y remains at its full employment level at Y bar, with natural level unemployment stay the same without accommodation. Therefore, people didn't lose the job. The only effect was, at the end, higher prices.